We are finishing up 4.2. So I just had a few more things to go over. The last thing that we wrote was about the common log, which is our base 10. So then the next thing that we need to remember is our natural logs. So if you see Ln, that means our natural log, which is log base E. So that's the natural log. Okay, and then domain. The domain consists of all x such that g of x is greater than 0. So the expression that's right beside our log is what has to be greater than 0.
Wait, fx equals log what?
Where are you at?
Under domain. Like, what is the base of log?
Oh, base b.
Oh.
Log base b of g of x. And so the expression has to be greater than 0. So if we are finding the domain f of x equals log base 4 of x plus 3, the way that you could do your domain is just look at this. X plus 3 has to be greater than 0. So then if you move 3 to the other side, you get x has to be greater than negative 3. So then our domain would be x values such that x is from negative 3 to infinity. That's our domain restrictions. And the reason for this is because if you do that, it equals x let's say y, then we would say 4 to the y equals x plus 3. If you do the exponent, your number, whenever you do the exponent, won't be negative. We want this to be greater than 0. Because the exponent is going to be positive. Okay, let's look at the next one. So we have log base 4 of x minus 5. So we would again set this x minus 5 to be greater than 0. Move 5 over by adding it, and x is greater than 5. So then it has to be greater than 5, so it's 5 to infinity. Let's do another one. I didn't put enough room, but I do want to do another one. Log of 2 minus x. Find the domain of log 2 minus x. So this is a base 10 if there's no log. I mean, if there's no base, it's base 10. But we're still doing the same thing. 2 minus x has to be greater than 0. So then we'd solve this out. This one, so it'd be negative 2 is greater than, or negative x is greater than negative 2. Divide by negative 1 all the way through, which would flip your inequality symbol, making this x is less than 2. So our domain would be, if it's less than 2, then it's negative infinity to 2 with parentheses around it. Okay, the other part of 4.2 is just graphing them and understanding how the function is shifted, translated, reflection, shrink. So I'm going to put in, let's see, where's our, we have a vertical asymptote. Here, I'll just show y'all in the book. These are like your parent functions of exponential compared to log. So this is our exponential function that we learned with 4.1. So see how it goes through 0, 1, it's increasing, going up. And we have a horizontal asymptote at x equals 0. So since they're inverses, they reflect across y equals x. So this is what the log function looks like. And it has a vertical asymptote where we'll never cross this x equals 0. So it's log base b of x. So that's when your base is greater than 1. When your base is between 0 and 1, you'll have, let's see, this is our f of x is b raised to the x power. This is our log function. You still have the horizontal and vertical asymptotes. Here's your horizontal 1, and here's your vertical asymptote. And then these are your transformations involving logs. So this is on page 483, if you want to look that up, if you need it while you're doing your assignment. Page 483. Y'all can get to the textbook online, or you can look at your hard copy. Okay, so here are some examples of the transformations that happen. So here is log base 4 of x. So it goes through 1, 0, and here's the function. When you do 3 plus log base 4 of x, that 3 translates it up 3 units. And then a reflection, just like whenever you have the linear parent function, whenever you have a reflection, it usually has like y equals x and then y equals negative x. That's your reflection. So it's the same thing. If you have log base 2 of x and then negative log base 2 of x, that's a reflection across the x-axis. And then a vertical asymptote, that's if we change the x that is our expression for the log, and that causes that vertical asymptote. It's still x equals 0, but it's a reflection across the y-axis. So you'll be doing some graphing on this. Okay, so let's get into 4.3. These are your properties. So properties of logarithms. So I'll let y'all write it down and then I'll talk about it. Don't worry about those right now. Let's just look at the rule. So our product rule is similar to our exponent product rule. So if you have two variables that have the same base, or two terms that have the same base, different exponents, and you're multiplying those two terms, then you add your exponents. So it's the same thing with log. When you have a log b and then m times n, that means you can expand it out to have log b of m plus log b of n. So if we have log base 4 of 7 times 5, then we can rewrite it as log base 4 of 7 plus log base 4 of 5. And then the next one, log of 10x. So remember that means log of 10. So we can write log base 10 of 10 plus log base 10 of x. So if we look back over here, remember log base b of b equals 1 because of this. So if we have log base 10 of 10, that equals 1. So it's 1 plus log base 10 of x, but that 10 doesn't really change anything. So I'm going to put it back to just log of x. Because if I don't have the 10 there, it still means the same thing, a base of 10. The next one, ln 7x. So remember, ln means our natural log. It's log base e. So we can write this as ln 7 plus ln x. And that's all we can do there. The next one, log of 100x. So that means log base 10 of 100 plus log base 10 of x. So we need to be able to simplify this more because it's 10 and then that's 100. If you were to do your, let's say this equals y, right? So it'd be 10 to the y equals 100, or 10 to the x, doesn't matter. What would that exponent be to make it 100? It'd be 2. So we can rewrite this as, this is 2, so it's 2 plus log of x. You don't have to have the base 10 there because that doesn't do anything for us. Okay, the quotient rule is the next one. So it's similar to the exponent quotient rule. So when you are dividing terms with the same base, then you can subtract them. So log base b of m over n means I can do log base b of m minus log base b of n. So here are some examples. So log base 7 of 19 over x would be log base 7 of 19 minus log base 7 of x. And that's all we can do on that one. So same with this other one, log base 8 of 23 over 11 would be log base 8 of 23 minus log base 8 of 11. Okay, so the next two deal with the natural log, log base e. So this would be ln e cubed minus ln 7 and there's a rule that says, well, we could just rewrite this as log base e of e3. This is similar to having that log with the base 10, because you'd say y, and you'd do this whole thing, e to the y equals e cubed. And so that means that y is 3. So this equals 3. So this rule means that ln e to the x equals x. Anytime you have ln e to the x, it's going to equal x. So that's what we can use to help us. So that's why this came out to 3, because that would be e to the third, which equals 3. So it's minus ln 7. Okay, so then this other one would be ln e5 minus ln 11. And using that same thing that we used last time, ln e to the x equals x, this equals 5. So 5 minus ln 11. So it's similar to the log base 10. So it has special features that go along with it. Okay, power rule is our last rule. Do you remember learning this in pre-cal? Yeah. Okay, so if we have a exponent of p right here, we could just take it right up front. So then here's an example that we can work out. So you take that out front, and it'd be 4 log base 5 of 7. Just take it over here. Okay. ln of x to the square root of x. So we need to rewrite this so it has an exponent instead of that square root. So we can rewrite the square root of x as x to the half power, which then you can take that up front. Half ln x. Then the last one, log 4x raised to the 5th power. Take that up front, so it's 5 log 4 of x. Okay, so the properties are, we're going to use a combination of all the properties to expand and condense expressions. Okay, so the first one is your product rule. Then we have our quotient rule. And then the power rule. Okay, so let's do log base b of x squared to the square root of y. Okay, what property can we do first? Yeah, the first one. So the log base b of x squared plus log base b square root of y. And then what would be the next rule we could use? Well, or how else could we convert it, I guess? Huh? What'd you say? Elena? Nothing? We can take this, right? So 2 log b of x. But then what about this one? What should this be changed to? 1 to the half. There you go. See, you're just scared to say it. Okay, what about the next one? Log base b of square root of 36 over square root of x minus 1. The whole thing is x square root. So it's division. So we'll do the quotient rule. Log base b of 36 minus log base b of square root of x plus 1. Could we simplify this more? Instead of having 36, could we have a number to a power?
6 squared.
Mm-hmm. So log base b of 6 squared. And then we'd take that down. So 2 log base b of 6. Okay, what about this next one? Maybe do it like that. So then we could take that out front and be half log base b of x plus 1. Is that all we can do on that one? Let's see. Okay, that's all we can do on that one. So I'd rewrite it. Okay, then 3 more examples and we're done. Condensing log expressions now. So addition means you can multiply them because they have the same base. So log of 25 times 4, which would give us log of 100. And that really means log of base 10 of 100. And going back to that rule, it would be like log base 10 of 10 squared equals 2. Okay, and then the next one, log of 5 plus log of 2. Log of 10. What does log of 10 equal?
1.
1. Yep. Two ln x plus 1/3 ln x plus 5. Okay, so let's translate this. 2 ln x. How can we rewrite that? We can take this up to the exponent. Remember that? We're going the opposite. So it'd be ln x squared plus We can take this up to the exponent. Ln x plus 5 to the 1/3. What does it mean whenever you have something to the 3rd power? Say that again. So we can rewrite it as the cube root. Can we condense it down a little bit more? If we're adding and they have the same base, what can we do to our expressions here? Yeah, multiply them. Okay, and that is it. So you have an assignment in Pearson, and then you also have a test review that you can go ahead and get started on since we have a test Friday.